Something big is happening behind Tesla's factory walls, something no one's fully talking about. Rumors say Elon Musk has cracked the code to producing 500 battery cells every second. That's not a typo. It's real, it's massive, and it's happening right now. It starts with a strange combo of table salt, water, and dry coating tech. Sound impossible? That's exactly what competitors thought. But what Tesla just revealed will change how we power cars, homes, and possibly entire cities. Stick around. This isn't the future. It's already begun. What is Elon Musk really hiding? What Tesla is planning for 2026 makes everything before now look like a warm-up. We're talking about production numbers so massive, so jaw-dropping, even the experts are struggling to believe them, too. In this video, you'll get the full breakdown, every detail of this secret master plan, every update that's been buried until now, and why this could reshape your future. So hit that subscribe button and turn on notification. Let's break through 177,759 subscribers together. Because what you're about to learn, no one else is showing you. How is Elon Musk secretly building to 5? Let's start with the big question. How is Elon Musk using next-level tech to push Tesla toward producing 500 batteries every second? Over the past 6 months, the game has changed. At Tesla's lithium refining facility near Corpus Christi, the kiln has fired up and is already processing raw materials. This marks the first real-world use of a low-waste refining method that uses salt and water, not harsh chemicals. The initial goal? Enough lithium for 50 gigawatt-hours annually, potentially scaling up to support production for 1 million cars. That's just the beginning. Tesla's battery team has also made major upgrades. 4,680 Gen 2 cell is lighter, and thanks to breakthroughs in dry electrode technology, the company is finally moving past previous bottlenecks that held back mass production. When clean, consistent lithium meets high-speed dry coating, 500 batteries a second is no longer a fantasy. It's a result of calculated decisions, pushing risk in-house, streamlining steps, and minimizing quality issues in real time. To put it in perspective, Tesla's targeting 536 battery cells per second. Their battery evolution, from early 18,650s in the Model S and X to the 2170s in the Model 3 and Y, has drastically improved energy density and lowered cost. But it was the 4,680 cell, unveiled in 2020, that truly changed the game. With a tableless design, it reduced resistance, boosted efficiency, and slashed manufacturing costs. Scaling, it wasn't easy. But now, with real momentum behind dry electrode lines, Tesla's battery production is entering a new phase. Tesla isn't just dominating EV, they're transforming energy storage too, with products like Powerwall and Megapack. While Gigafactory Nevada remains their battery hub, Lathrop, California is leading Megapack production. The company's also doubling down on LFP batteries, which offer longer life and lower cost, while keeping a close eye on solid-state battery advancements that promise even faster charging and greater energy density. Of course, all of this hinges on materials. Lithium for charge, nickel for energy density, cobalt for cathode stability, and graphite for the anode. Unlike traditional automakers, Tesla is vertically integrating, even building its own lithium refinery in Texas to secure its supply chain. Once materials are secured, they're refined, coated onto foils, and assembled into cylindrical cells, Tesla's preferred format. The cells go through a charge-discharge cycle and aging process, then get stacked, into modules and packs. Tesla often skips the module step entirely with cell-to-pack tech, boosting energy density and reducing weight. With over 1.78 million vehicles sold in 2024, Tesla needed almost 7 billion cells. That includes 2,976 cells for each Model 3 Y standard range, 4,416 for long range, 7,180 for the Model S X1344 for Cybertruck, their energy storage division. Alone could demand over 10 billion cells, exceeding their needs. To meet this, Tesla works with multiple suppliers: Panasonic, LG Energy Solutions, CATL, and even BYD, a direct EV. BYD LFP batteries, which are lower in energy density than NMC but cheaper and longer lasting, are used in standard Tesla models in China, making up around 40% of total battery supply for those cars. Tesla has tested LFP tech in the US, but supply constraints mean they still rely on a diversified supplier base. Yet, their goal remains more in-house control. Acquiring Maxwell Technologies in 2019 was a major step, helping Tesla advance dry electrode breakthroughs. Today, over 100 million 4,680 cells have been produced. The Nevada Gigafactory is expanding to hit 100 GWh annually, enough to power 1.5 million vehicles per year. Still, Tesla isn't going it alone. They continue to work with Panasonic, LG, Samsung, and now China's Eve Energy to scale operations. Before we move on, what shocked you the most so far? Was it the salt plus water lithium refining, the dry electrode win, or the kiln finally firing up? Comment below. Let's compare notes. In just 18 months, Tesla built something that usually takes 3-5 years. A fully functional lithium refinery in Texas. Not a sketch. Not a demo. A kiln fired up, refining raw material into power. And it's already producing. Experts said it couldn't be done that fast. Elon Musk said, "Watch us." The drone footage, the tech, the hiring surge, it's all pointing to one thing. Tesla is gearing up for something massive in 2026. But is this a turning point for EV dominance? Or the opening move in a much bigger strategy? How close is Tesla's lithium refining plant to full scale by 2026? Now to the big follow-up. How close is Tesla's lithium refinery to hitting full capacity by 2026? The story out of Robstown, Texas, just took a leap from plans to production. Tesla has officially fired up the kiln and processed its first spodumene 18 months after breaking ground. That's incredibly fast. Drone shots show the foundation for production line 1 taking shape, along with new power substations and the rotating kiln plus cooler system installed and ready. Tesla isn't just dreaming. Line 1 is nearly operational, and Line 2 is in early construction. The goal? Refine enough lithium for 50 GWh per year, securing their supply chain at scale. While there's still work ahead, real throughput is finally within reach. Tesla's job listings reflect the ramp. Over 40 open roles, from logistics and metallurgy to site managers, are up on the careers page, showing an operational push is underway. In its Q4 2024 earnings, Tesla confirmed production of its first spodumene concentrate, claiming it's the fastest any plant has achieved this outside Asia. The plant is expected to be fully online in 2025, making Tesla increasingly self-sufficient in lithium refining. And the battery race is heating up on all fronts. Next-gen superchargers are rolling out with up to 500 kW of power, cutting charging times significantly, especially for Cybertruck. Other companies are aiming for 350 W+ systems that promise full charges in under 15 minutes. Battery density is also improving. The focus is on longer range, lighter packs, and lowering costs. There's even active research into batteries that last 1 million miles, a game changer for EV longevity. Recycling is key too. Tesla commits to 100% recycling of used lithium-ion batteries. Companies like Redwood Materials and Li-Cycle are developing systems to recover critical elements, building a circular battery economy. And Tesla isn't alone in building lithium independence. Stardust Power broke ground on a $1.02 billion refinery in Oklahoma, aiming for 50,000 tons of battery-grade lithium per year. The Muskogee location is strategic, central for shipping, near water transport routes, and with a local workforce skilled in refining from the oil and gas sector. The facility will use barge transport via the McClellan Care navigation system, making it both cost-effective and efficient. Backed by $257 million in federal and state incentives, Stardust Power's plant could complement Tesla's output and help meet the skyrocketing demand for US-sourced lithium. Finally, if the updates from Robstown left your head spinning, you're not alone. We've just uncovered a major piece of Tesla's massive battery production machine, and it could change everything from EV prices to delivery timelines, and even how your home stores energy. While most automakers wait on suppliers, Tesla is flipping the script, refining its own lithium, scaling its own batteries, and even rewriting how batteries are made. The 4,680 dry electrode breakthrough? That was just the opening move. Now, Tesla's planning for 10 billion battery cells a year. Why is nobody else doing this? Fuzz playing a different game and winning. In this video, we unpack the hidden infrastructure, the insane scale, and the vertical integration plan that could make Tesla unstoppable by 2026. What they're building might just outlive the car itself. Want to dive deeper? We'll break down new drone footage, technical specs, and the next-gen aluminum-ion battery in our next video. Make sure you're subscribed so you don't miss it. See you next time, where we continue decoding the future of Tesla and the EV evolution.